Thank you, everyone, for joining us today on looking at what's new in CAM and CNC machining in this SOLIDWORKS 2020 webinar series. I'm Daniel Lyon, one of the CAMWorks specialists and CAM specialists at Hawkridge Systems. We're going to be looking at a few different things today. Basically, we're going to cover a little bit about what's new in SOLIDWORKS CAM and CAMWorks in 2020. There's also been a new product launch this year, so it's not a secret anymore. It's been released since about August, beginning of August, but there's a new product that was released this year from CAMWorks, and we'll go into the details of that and basically a little bit more about it. And we'll look at also just some services that we offer, just in case you're maybe not familiar with what we can provide for you as a service and to help you guys out, get your shop floor and get all of your programming and your manufacturing basically streamlined as much as possible. So we'll just have a little slide at the end there that just shows us some of the things that we offer to different customers and some of the things that people have requested in the past. But let's get underway and let's take a look at some of the great new enhancements in CAM. So these are some of the new enhancements in SOLIDWORKS CAM. So if you're not familiar, SOLIDWORKS CAM was released in 2018. Basically, they partnered with CAMWorks to produce a CAM package for milling and turning. And basically, the development is still very, very close between the two. So CAMWorks, the development is actually coinciding together with CAMWorks products. So anything that you see in SOLIDWORKS CAM is automatically going to be in CAMWorks as well. So basically, some of the new enhancements are we've got now tabbing capabilities. So if you guys run things like CNC routers or CNC lasers, plasma cutters, that type of thing, where you've got kind of heat or vacuum tables or whatever, heat going into the part causing distortion and that type of thing is what I meant. And vacuum tables where you've got to maintain pressure and vacuum basically to keep the part in place so you don't have these little parts moving around. We've now got a function to support that dedicated to doing that type of work. In previous years, we used to have to draw little sketches and things like that and use void areas, and that was just getting a little bit tedious. So now they added the tabbing capability so that we can actually do that more automated. Subroutines per operation. So for those guys who love to use Control-C, Control-V, or Control-X, Control-V for cut and paste and making your own subroutines and custom programs and stuff like that, you can now actually output those per operation. So previously what we had supported was we could output M98 programs for pieces in an assembly. So you can just program, produce a code basically for one piece and then pattern it across essentially, or repeat it for the rest of the pieces without having to basically multiply your code for every piece that you've got. Now we can actually do it on an individual operation by operation basis. So if you just want one operation that says put this in M98 or M97 mode, you can now do that in there, and I'll show you the flags for that as well. Spindle direction linked to hand of cut and turning, and also mill turn in CAMWorks. Basically, some of you may not be familiar with it, but in milling, we link the hand of cut of the tool. So if you've got a right-hand tool, you output an MO3. You've got a left-hand tool, you output your MO4. And basically, that was great. In turning, that was never the case. You had to switch it between clockwise and counterclockwise for your spindle in turning, and there was no link there. So now in turning, in mill turn, we now have a link to basically link the tool insert orientation, so whether it's a right-hand or left-hand tool, to the clockwise and counterclockwise direction in there as well. And I'll walk you through some of that and where it is and how it's done. We now have support for tapered multi-point thread mills. So before we used to be able to support multi-point thread mills, but not tapered multi-ones. So we've now got that capability. I'll walk you through that. And there's been some fantastic new enhancements in the tool definition. So the ability to store things like a tool ID, a vendor, pretty important for some of you guys if you're working with different like tooling suppliers and things like that, and fixturing and that type of thing. We've now got the ability to actually assign vendors and descriptions to those tools, and also just define a tool whether it's center cutting or not. Previously, when you looked at an end mill, basically the end mill in physical life, you know if it was either center cutting or non-center cutting. But in CAMWorks and SOLIDWORKS CAM, there was no real differentiation between that. So now we've actually got that capability, and that's going to help you out. It's actually going to flag you with an error message. So if you try and plunge into a component in a rough mill or something like that, and you've got the setting set to non-center cutting, it's going to give you a warning saying, hey, you're being a bit careful here. Just be cautious. Double check to make sure that you're using the right tool and it's exactly what you want to do. So that's a nice new option there. And two of my favorite new enhancements that they've released is automatic feature recognition for curves for chamfering. Now that's a bit of a long phrase to say in one, but basically I'll explain what that does. But it is a fantastic way of deburring your parts and things like that on the machine. So rather than having to mess around with it by doing things manually, you've got an automatic feature recognition for that too. And probably my number one favorite enhancement is the probing capabilities, and that actually is going to come in SOLIDWORKS CAM Professional. I'll just show you another couple more things that is also in what's new. Couldn't fit them all in one. There's so many updates. Advanced Editive Toolpath. They've adjusted some of the editing capabilities. Some of you might not know that it's there, but I'll show you kind of what you can do with it. Before there was a little dialog box that you would come up and it would kind of just float around the screen and then just put your code in somewhere. So I'll show you that they've just changed kind of the interface to that a little bit just to make it a little bit easier. And also some really nice customization settings in the technology database. So if you're used to kind of adjusting the columns or scrolling the bars across and things like that, you can now save some of those customizations that you do to basically a file, and then you can reload those up on different machines and things like that. So, and also to support some of the new subroutine capability and subprogram capability and the probing capability, they also released a new universal post generator called UPG2. So going forward, that will be the one that you'll need to compile your post with to get the probing support and the subroutine subprogram support. The other thing in CAMWorks side of things, we'll just take a look at this and then we'll dive right into the software, and I'll walk you through some of these enhancements and things like that. But on the CAMWorks side of it, obviously it includes all of the stuff that we just talked about in SOLIDWORKS CAM, because essentially they're partnered together, they're going to update together. Some just nice to haves, really. Some of the ones that, I mean, it's not rocket science, but some of the stuff that you sometimes get a little bit frustrated with in the past, like why is this coming here and why is it not going in, like the toolpath not dropping around the sides of this part, or what's going on? Why is it not dropping into this hole, or why is it dropping into this hole? They've added some display of automatic contain areas in 3-axis. So that was a common one that people used to get messed up with and sometimes just struggle with a little bit, and just to make things a little bit easier so that you've got a visual on, hey, what is actually going on with those contain areas and why is my toolpath going in this region or not going in this region. Similar type of deal in multi-axis. Again, just display of clearance planes and things like that. When you're in multi-axis and you've got full 5-axis capability, you've got basically planes coming off of all sorts of different directions and things like that. You want to make sure that whenever you're specifying something, that what you're specifying is clear and accurate. You want to know where is the clearance plane and what difference it is, because your clearance plane might not be where you think it's going to be. So it just helps with a little visual reference there. A couple of years ago or a year ago, CAMWorks also added the additive manufacturing module to their suite that uses a company called Materialize, basically for doing essentially what you do in a CAM system, but for 3D printers. So rather than programming CNC mills and lathes, you're essentially programming in a standalone package in one interface 3D printed files. And then you use essentially they call it a build processor, but essentially it's the equivalent of a post processor in a CNC world. And that basically translates the code to a particular printer. So now they actually have support for doing assemblies. So if you want to stack a gazillion parts on your print bed, and lay them all out and optimize that. Basically, you can certainly do that now in the additive manufacturing. And just to keep those lovely people in IT off your case, there's now a command line installer, an MSI installer. So if you're responsible for large deployments of CAMWorks and things like that across your company, that used to be a little bit a headache because you had to almost go to each computer and install it individually and things like that. And if you've got multiple users, then that can take some time. So they added this command line or MSI installer that you can basically use it as like a deployment. So you can just keep the IT guys as happy as possible and off your case. Let's take a look at some of those enhancements in the real life, and we'll see what they're doing. So if you guys joined me last year for the What's New in 2019, this assembly was a fantastic example of some of the capabilities in there. Basically, as an amplifier for a stereo with a few heat sinks and things like that. And we looked at this as an example of basically making machine-specific preferences. So you've maybe got a bunch of lasers and mills and things like that in your shop. Obviously, a laser cuts differently to a mill. You've got curve thicknesses instead of tools. You've got no roughing going on in a laser and things like that. So this example last year was used for highlighting basically capabilities for doing lasers, but it also worked perfectly to show you the tabbing side of things. So I was going to go in and just look at these guys. Usually you're kind of working with tabbing on smaller geometries just to kind of keep things in space so that you don't have all these little bits flying around, or if there's a vacuum or whatever, it needs to actually get enough pressure to suck down on it. There isn't usually the surface area on these small parts to be able to do that. So we're going to just take a look at the new tabbing function. It isn't a contour mill because that's predominantly what you're using in those type of profiling equipments like routers, plasmas, water jets, lasers, and those type of things. So it is a contour mill. I've just got a tool essentially as my curve thickness over here, but this is the new enhancement right here, tab cutting capabilities. So what we do is we can turn it on, and you can see what I mean by tabbing is just adding these little webs in here, in this image here, so that it keeps the part in situ. So it's not sitting there moving around, and then ultimately once you've finished that sheet, you flex it a little bit, you break that tab off, and away you go. You've got your part. So we've got some controls in here. This is where we can specify things like, you'll see the actual tabs come up in here in pink in my screen. Basically, we can control things like the length of them. Let's go down a little bit there on the length. So we don't want to break our fingers trying to get this thing off. We can control the thickness of them. So in this case, it's giving me an error because I've basically gone too low, but I can set it something super low. So if I was using like a router, for example, and I just want to leave a really thin web at the bottom, but still cut, say, 5/8 of a 3/4 inch sheet. So I've got just a little bit of rigidity at the bottom so it does stay in place. I can adjust the thickness down to a level so that it makes sense. Obviously, this is a laser. If I run the torch straight across that, it's going to cut through it. So I'm just going to crank it back up to my material thickness here. I guess it was 0.08 should be. That'll be fine, whatever. And you can specify a number of tabs and things like that over here. So if I go and say, okay, I want, say, 3 tabs around here, it's going to distribute them around the part. I can offset them as well, so I can shift them along a different position and things like that. I can also tell it what is the minimum segment length. So if I've got a really short segment, like, I don't know, this edge over here is maybe only 1/8 of an inch long, I probably might not want a tab in that region because I might want a slightly longer tab. So you can kind of tell it a minimum segment length, and it will go and look and only put segments or tabs on that geometry where it's longer than that distance. So I'm just going to put a couple of tabs in here, one on either side, basically. And then you can control what happens in that particular region. So is it going to feed over? So on a router, for example, you might want it to basically just lift up a little bit and then feed over and cut through that extra 5/8 of material in here. or I might want it to retract to the clearance plane or use like a lead in, lead out defined from my operation. So in this case, because it's a laser, I'm just going to tell it to wrap it up over here. So now it basically will come around here, turn off the beam, wrap it across, turn on the beam on the entry on the way down, and it's doing that all the way down here. And it's patterning across in here because of my instances in my assembly. So that's a great new option that they've got there. And that's the tabbing capabilities. So very simple little tool, but effective, saves me having to draw things like sketches and things like that. So the other new enhancement that I mentioned was the ability to output subroutines. So the M98 subroutines. So obviously we've got a number of different components in here. I'm not going to count them all, but you can see all these are identical to each other. But rather than outputting an individual code for each one of these, that is essentially the same toolpath that's replicated however many times that I've got in here. What I essentially want to do is just shorten the code down and loop through that code, and that's what that M98 program or M97 program capability gets me on my machine. I can reduce the actual code going into the machine so I don't just clog up the memory with basically repetitive program and stuff like that. So we always used to have that, but it was always on an individual part. So in an assembly like this, you'd basically turn it on and it would just be on for everything. Or it would be on for a linear pattern in a part file, for example. So if you've got something like these slots, for example, and you pattern them, so you program one and you patterned it across here, you'd be able to get the M98 capability for doing that. But now it's on an operation by operation basis. So I can go into here and say, hey, I want to output subroutines for this, and it's going to output the G52, the work coordinate shift, and then the M98 P03 or M97 P001 or whatever, and basically loop through the code. And this is where you would normally control it in the operation side of things, in the posting tab. You will need to make sure that your post processor supports that capability. But right up here is also where you can turn it on as well. So right in once you've selected your post processor over here, and you go and say, okay, here's my subroutines. This is now your controls. Do you want to output them at all? Well, no, maybe not, and it will just go to the regular, repeat the code that many times. You can do it for all operations, and it just grays out some of the other capabilities, or as defined per operation. And I can also control it at a global level over here. So if I want to turn on, say, those slots and make those slots, for example, output as a subroutine, just saving on the code and things like that, I can do that and basically loop through them. So another great new enhancement from CAMWorks and SOLIDWORKS CAM there. So with that, we'll switch over to some of the turning side of it. I mentioned the hand of cut. So in this particular part, I've got this Olin's damper from a Panigale Ducati Superbike, and it's the head end of it where all of the damping goes on and all of the rebound and bound adjustments go on. And it's a pretty complicated part in here, but we split it into two separate operations. So this is the thing I just love about CAMWorks is I don't have to have two separate files to manage and things like that and cause a whole bunch of headaches with engineering, creating different versions, and then having all of the guys in the shop floor going, okay, well, I've got to update this lathe program now because you changed your model, and update this mill program now that's a separate file to that because I've basically got it. It's all just in one SOLIDWORKS file in this case. So in here I've got a lathe program, but I mentioned the ability to link the actual the spindle direction to the hand of cut. So in here I've got my right hand, left hand controls in here. In the milling side, like I said, this was always the case. It was always linked to the hand of the tool. So MO3 would come on with a right hand tool and MO4 would come on with a left hand tool. But in turning, there wasn't that capabilities, and they just added that this year. So left and right here is now going to trigger this clockwise and counterclockwise direction over here. So if I switch it to a left hand, you'll see it will go counterclockwise. If I switch it back to a right hand, it will go basically clockwise. You can override that as well. There are some machines that get jacked up just because of the gearing in the heads and stuff like that. So or in the actual different machines require different orientations. You can override that, and it will basically give you the option just to go, hey, for this left-hand tool, I want it to go counterclockwise, or I want it to go clockwise. So you've got the capabilities here to go through and basically adjust those kind of cuts and things like that. So this was the turning work I was just doing in the boring here and doing this lathe work on the end here. And then I flipped it over, stuck it in the mill side of it, and basically imported my stock from the lathe side. So I knew exactly what material I was working with and where I could clamp onto. So I've got it clamped down here. And we're going to stick this in like a 5-axis machine and try and get as much of this done as possible in one shot. So some of the other really nice enhancements, they added this advanced edit capability. Or they didn't add it, but they actually improved it. So some of you might not know this, but say for instance, I don't know, you're in one of these operations down here, for example, and you've got some oddball move, or you want to change the feed rate at some particular point in the code, or you just want to edit the code in some sort of way. You can actually expand the actual operation here and right click and edit the toolpath. And this advanced edit toolpath is where the enhancements have been made. So what they've done here is just simplify the interface a little bit. You've got some controls up here to kind of play through the actual moves in here. And you're essentially editing directly the toolpath in here. So this is all the @CL data, the cutter location data essentially that the software is running off of. We've got display options just like your step through toolpath and things like that. But the enhancement is being down here. They've taken this little box that used to kind of float around over here and basically integrated it into the interface a little bit more. So if I wanted to put like a feed rate change, say at this point in the code, I can just come in here and say insert new feed rate record and tell it what I want it to do. So if I want to maybe slow it down or whatever, so it was, I don't know, it's a sharp corner or something like that, I can go and say, hey, make that 50 inches a minute, for example. Insert, and I've now got a feed rate change right in here, basically. So I can come through, and it's just a simplified way of doing edits to your toolpath, basically. It's just a nicer, cleaner looking interface. You don't have little windows flying around your screen and things like that. Just a nice, clean interface that you can do. And what it will do is it will actually lock the toolpath as well. So if you do make those changes, you don't want typically those updates to be wiped out by a rebuild and things like that. You'll get this warning here to lock it. I'm not going to lock it in this case. I'm just going to leave it. I don't really need it to be locked. But there's that advanced edit capability there, and you just access it from expanding the operations and right-clicking on the actual feature underneath, and you'll get access to that. So I mentioned also there was support for the tapered multi-point thread mills. So now we can come in here, we can look at our thread mills that go and cut our 1/2-inch 14 MPT threads in these two rebound and bound bores here. And you can see now we've got this taper angle support on a multi-point thread mill. So we can now support that type of tool and basically run with it. The other enhancements that I mentioned, they also included better definition of the tool and things like that. So you had always your tool comment and things like that. You've got all of your values here, but what about things like tool vendor, or some machines require like a tool ID instead of a tool number. You're calling it using like a script rather than a tool station number, for example. You're not using like T1 or T2. You're actually using a verbiage or a set of phrases basically to call a tool change. In here, we've now got this option down here for additional details. So I've just put some details in here for things like tool ID. Now that could be different to my tool comment. You'll see I've got a slightly different one. Just maybe that's your own identification. Maybe it's not just a word, but it's a part number or something like that you want to just store with that tool. So if you break it, you know exactly which tool it was. You come in here, you go, right, I need to order a new one of those from OSG, for example. or Kennametal or ISCAR or whoever. You can also give it a description as well. So more descriptive. I've just basically copied the stuff down here, but it could be whatever you want it to be. Holder details as well. I don't know, maybe you've got some specific holder that you need to use for a certain tool or something like that. You can go and plug in some details there as well. So another great new set of enhancements there for controlling things like vendors and tool IDs and descriptions. I also mentioned there was an enhancement for things like center cutting and non-center cutting tools. So I've got a bunch of roughing operations in here that are using VoluMill that basically aren't using a center cutting tool. So it's got a non-center cutting. You can see there's basically right at the tip of my tool here on the preview, there's a little recess in there. And that's just this flag right here that's causing that recess. So it's just a way of identifying that, hey, actually that tool can cut on the center, this tool can't cut on the center. So, and like I said, if it's set like this, if you start using your entry methods and things like that for plunge, and you've got it set to non-center cutting, it's going to give you a little dialog box on the screen there just to say, hey, just be careful. This is what you're doing. Are you sure you want to go and do that? So, so just another little enhancement. Just helps out differentiate tools in your database and things like that. So you're not having to remember the little details. You can just focus on the big stuff. Another fantastic new enhancement that they did in here was they added this ability as part of your feature recognition. And some of these enhancements will be in a slightly later service pack of SOLIDWORKS CAM. This one will be in SOLIDWORKS CAM. It's not in the first service pack, but it will be coming in a later service pack. So I should just point that out. It will be in, it is in 2020, as you can see in CAMWorks, but it will be coming on some of these into SOLIDWORKS CAM as well. But they've added this great new option here for curve features for chamfering. So what do I mean by that? Well, basically you've got some controls over here to control where it finds these types of geometries and things like that. But it means if I come over here and I hit my extract machinable features, what it's going to do is look at the model and see if it can find things like sharp corners and things like that where you might want to deburr them. So things like the top edge up here, I don't want a nice razor sharp edge there. It might nick the seal as I'm putting in the bore or whatever. I just want to deburr some of this stuff. So it will actually go and find curve features in the model within certain conditions to go and deburr things essentially. So it's just going to run through a few feature recognition here. We'll just lock that. That's just the rebuild warning because I messed with the toolpath earlier. It's trying to regenerate that one there basically. But in here you'll see it's going through and finding now curve features. Let's just get rid of this guy once it's gone out of the way. So clever little things like this, right? I might not want a sharp edge, knife edge right there. I might just want to come in and basically deburr that and deburr some of these guys around the top up here. Same thing with this. I might want to run and deburr this top edge. I might want to come in here, deburr this bore and this bore, but maybe this guy right down here, I don't want to do. So I can just hit edit and I can just remove it. But it means that I don't have to sit there manually creating a whole bunch of these to start with myself. So I can kind of come through here. I can just deselect it for that. Click on my end condition. Click on the green check. And now I've got deburring over here. All sorts of things like this. Now this one is one example that I probably wouldn't want to deburr, so I'm just going to delete it. Don't like it, simply get rid of it. But things like the bore up here, or sorry, the outside diameter of this boss right here, another great one. And this over here on the opposite side as well. So it just means that I can quickly come through here and go, okay, generate those operations. And I'd do some reordering of this to put them in the right order. But it means I can come through here and generate toolpath to go and deburr some of this stuff. So you'll see right there, you'll see right here. And you can control the depth of the chamfers and things like that. It's just using your strategies in your database, so you can control this and set, well, I deburr everything at 10 thou. Go in and change it, save it back to your database, and it'll do 10 thou next time. So the other nice thing is that you can do with this is, say for instance, I've got like this here. I've got an issue with this particular one. If I just look straight down onto this setup here, another great way of doing it is just using this right click on the setup here, set view, setup XY. It kicks me straight down onto here in the SOLIDWORKS model, so I'm not having to guess what it is. That's not a new enhancement, but it's a fantastic little tool that they had in here for a few years. So, but in this case, I can't get to this. It's going to gouge this top edge up here. I can always come in and adjust this avoid allowance, so I can crank that up and say, okay, maybe make it 100%, moving it away from the ends here. Maybe I need to go a bit more, 200%. So I can shift it along and move the actual point so I can do it, or I can just redefine that bit of the thing with a sketch if I need it to as well. So another great new enhancement that they did, just to quickly go and deburr pods rather than spending hours just putting in chamfers wherever you want to manually, basically. Now, next up is one of my ultimate favorites, and that's the probing capabilities. So basically in here, what we've got is now the ability to come in and add a probing operation. So in this case, maybe we want to go and probe the top of the stock and set the work offset correctly. I can come in here, click a couple of buttons, and tell it to update my work coordinate to G54, or use whatever my current setup is set to. Over here, that's what this is doing right now. It's going to now update my current work offset to whatever it's set in the work offset tab up in that setup, basically. Or I can just uncheck it and go, hey, actually update it to work offset G55 or whatever is this new point here. And basically what it's giving me is the ability to probe a part, and probing is fantastic. It's a huge time saver. On most machines, it's pretty, on most new machines, it's almost a standard requirement. It's almost a standard fitment in a lot of them, just because of the time savings that you can get. So in here, being able to probe those quickly just by clicking a couple of buttons over here, you can do all sort of protected moves and control the feed rates and things like that. And there's a whole bunch of different types in here. It's currently just set to web because now it's just probing my stock right there. So I would just drag that up here, and basically now I'm probing that stock using my Renishaw or whatever probe that I want to use. But I was thinking about this and I was like, well, what else can we use it for? Maybe you're doing in-process inspection and things like that. There's obviously some people question whether you can rely on the machine that cut the part to measure it also, but essentially if you want just an idea whilst it's in the machine and it's jigged up and in its fixture and ready to go, you might want to go and look at probing like a bore, for instance, over here. And I was like, well, how's the operator going to know exactly what size that boring operation is going to be? Well, he usually goes in and checks his blueprint, right? So he goes, okay, here's my bore size right here with its tolerance. A few years ago, CAMWorks added tolerance-based machining. So like, we came in here, and you can actually go and put these in yourself. If you've got inspection documents and things like that you want to do, you could actually put these dimensions in your own models, basically. Come in here, just using some of the MBD capabilities, and go and put those tolerances in as you see fit. So in this case, I want a +2 thou here, -0 tolerance in here, basically, on that bore. I've got my dimension now, but how can I leverage that in terms of CAM? Well, in my feature tree, my hole's currently set to drilled, but I can't drill that because it's got such a tight tolerance. So what I can do is I can pull my TBM in, my tolerance-based machining. I can tell it to go recognize the ranges and things like that. It's already actually done it for me right here, just based on that tolerance that I just put in here. So I can customize these ranges using some of my machine control settings up here, basically. But I can say, okay, between a 2 thou tolerance range, basically, you're in a boring strategy, and it will also tell you whether it's oversized, undersized, or nominal. So in this case, because I've got a +2 and -0, but the model is modeled at the basically the 9375, I'm in an oversized scheme, and it's telling me that from this little one right here. I'm using this particular strategy. So I might have a slight different way of doing things for things which are oversized versus undersized. But it means that I can hit paste. It will go and change that strategy over here to bore now. And then I can just go, okay, right, I'll generate my operations and regenerate those. So it's no longer drilling. It's now going to center drill, and bore. But usually when you're boring things like that, maybe you've got like an adjustable boring head or whatever, you want to go and make sure that it's correct. So you could come in here and go, hey, actually, I want to probe that bore right here. So if I click on that bore, it looks like it's trying to do MBD stuff at the minute, sorry. If I go in here and go probing operation, we want to go into here, probe that, click on that probe. We're now probing that bore using a bore cycle. And I didn't have to switch this. There's different ways of defining things. There's lots of different probing cycles that you can have. Obviously, with a circular hole like this that I was selecting, it limited me to the two ones which were basically boring style probing cycles. But you've got multiple different ones, but it will switch as soon as you click on a face to one of the cycles, and you can switch it as you see fit to do that. And you can set where you want to go. So if you want to set your Z depth to, maybe you've got a critical dimension or something like that you need to come in and avoid, or maybe there's a boss or something like that halfway down, you can adjust your positions of where that's probing so you can get it right on spec. And then you might just go and say, okay, well, I want to put in a post operation in here afterwards. And I'm just showing some of the existing functionality, but kind of all together to make it a one-time deal, basically. And you can hit add comments to this and say, hey, check the bore spec is 0.9375, dia plus 002 minus 0. And that's going to come right out in the code, so the operator knows exactly, okay, I've got this boring tool now selected. It's going to go and bore it. Now I'm going to go and grab my probe. Make sure you basically stop the machine at that point. It's going to stop it automatically because of this program stop, and give the operator right on the control, check the bore, this is the diameters and things like that. A great way of doing things with the probing cycles, and a fantastic new announcement to 2020. So that's some of the new probing capabilities. Some of the other enhancements that I mentioned were things like the automatic contain areas and things like that, and just display of them. We're not talking about kind of enhancements that automatically program the part for you, walk away and disappear, and you're basically sat there being driven home by your Tesla or whatever. We're talking about just nice to haves that sometimes you get little frustrations or whatever. You'd remember have to, okay, I got to do this and do this, but things like this. I'm in my advanced in a 3-axis toolpath here, kind of going and doing some finishing work over here. Why is the toolpath staying away from this boundary? Why is it not going any further past? Well, I've now got this kind of yellow reference to say, okay, well, the tool is going to drop in this hole, or it's going to stay away from this hole, depending on what I set it to. So if I set it to outer silhouette, okay, well, it's no longer, it's going to drop in that hole because there's nothing stopping it. But if I set it to stock, it's going to use that profile. Or if I set it to bounding box, it's going to use the bounding box or the geometry. So just visual references like that, just to help you out understand what's going on. So great enhancements there. Another one was the clearance plane settings in multi-axis, and this is the type of thing that gets kind of tricky after a while. Maybe you're tired and you're not feeling too well and you need a coffee or whatever, but you're wondering, well, when I set this to plane in Z, does it mean Z here like the top above here, or does it mean the Z of the setup and things like that? So currently this particular setup, if I go right click that view setup XY, it's going down onto that setup right there. And it's trying to machine the outside contour of this and basically go and do it. But in here, I want to be able to visualize where that clearance plane is. So when I set plane in Z, it now means 4 inches is going to be right where that green box is, basically. And it will change if you're doing cylinder about X or cylinder about Z or whatever. You'll see that will actually update with the new preferences. But it just means you can visualize a lot better. You're not having to guesstimate or figure out or make sure your head's in gear and working. It's just giving you those visual clues. The other thing that I wanted to mention here is also you'll see a lot of CAM companies that are talking about barrel cutters and things like that. And just as a side note, there's a lot of people talking about these tools called conical barrel cutters and barrel cutters and things like that, different types. A conical barrel cutter is nothing more than a tapered ball end mill. Basically, if you listen to a CAM company and they start using the phrase tapered conical barrel cutters and things like that, just ignore it. It's basically a tapered ball end mill. If you're talking about true barrel cutters where you've got an actual thing that looks like a beer barrel or a keg basically at the bottom and it's got a big radius to run down a wall, sure, that's a barrel cutter, but a conical barrel cutter is not. It's just a tapered ball end mill. So just be aware of that stuff. Essentially, we support tapered ball end mills. If your software doesn't, then you've got to question how good of a 5-axis tool it is really. But in here, basically, we can support and program through those. But that kept coming up in questions quite frequently during demonstrations, so I figured I'd just touch on that whilst everyone's on the phone here. The other new enhancements, like I said, were the 3D print assemblies and the command line installer for installing CAMWorks on deployments for multiple users and things like that. Now, the other new exciting enhancement was a new tool called CAMWorks SHOPFLOOR. So this is the new product. It got released in August, so it's not really a new product announcement because we've been talking about it for a little bit, but some of you guys might not be familiar with essentially ShopFLOOR and what it is. But the easiest way I can explain it to people is if you think of an eDrawings file, but with CAM data. It's basically something that is lightweight. You can open it on a tablet, but it gives the operators more information. It gives them a simulation of the toolpath. It gives them a list of the tools, the protrusions. It gives them the G-code. It gives them the simulation and a whole bunch of other stuff. And the reason this kind of came about really was because of a bunch of issues that occur on the shop floor. The amount of times that I hear some of the stories is unreal. Operator sets up the origin location at the incorrect location on the part. So say for instance you went and programmed it and you set it up as the back left corner of the stock at the top, sure. But the operator goes and says, okay, well I thought that was at the bottom or whatever. And now he's set the machine up, he's got all of his tools indicated in, but now you've got a program that's not matching up to that. Obviously in CAMWorks it's just a simple flick of a switch to basically move the origin point around as you need to. But in reality the issue shouldn't occur, and the issue occurs because the communication to the shop floor is not accurate. Worst case is you're using a screenshot. Sometimes you can be using like setup sheets and things like that, or you might be making a SOLIDWORKS drawing. But in here, operator setting up the incorrect origin location is a pretty common one. Incorrect tool setup. Maybe the operator didn't know exactly what length tool what tool protrusion to actually set up in the machine. Again, what do I need for that particular job? The last thing you want to do is go crashing that machine because of the tooling not matching up or whatever. So giving them the right information for tool lengths and tool reach and things like that. Even just the machine doing something unexpected, right? All of a sudden the machine stops with a program stop, like I just did for the bore. Why is it stopping all of a sudden? What am I doing? Maybe they've got to look at the code and see what's going on and things like that, or just see it. It's hard to visualize when you're in a kind of a programmer and operator style setup, what each person had in their head when they were thinking about it. Machining the wrong revision of the part. We go into so many shops where manufacturing and engineering is like walking into two different countries. They're completely different environments. No one's talking to each other. They're speaking different languages. They're using different files, but ultimately they're all making one product. And usually the case is engineering throws it over the wall to manufacturing. Manufacturing starts producing the code. They produce the part. They produce a bunch, store them, and all of a sudden, engineering's changed the revision to Rev B or Rev C or whatever. Shop floor doesn't get updated, so they keep producing Rev A, and all of a sudden you've got a bunch of parts that you're either scrap or you've got to store for reuse later or rework it or whatever. Other things like, does the part need in-process inspection? Like I was saying with the probing cycles. What's happening in there with the probing? What's going on with it? Why is it doing this? Why is it doing that? All those type of things. Even simple things like code edits. If the operator is making edits to the code of the machine, and he's doing that in the control, why is he doing it in the control? You could be doing it in the shop floor in the actual G code itself, rather than doing it on the machine and then just pulling the code into the machine. Manual transfer of the code to the machine as well. So you're not drip feeding code into the machine. You've got to basically walk across with USBs and things like that, and maybe something occurs, you grab the wrong version or whatever. But essentially, shop floor is designed to kind of resolve some of these issues that you see on a regular basis. So essentially, think of it like e-drawings, but with all of the CAM stuff. Essentially, what it is doing is your SOLIDWORKS and CAMWorks have all of your programs in it. Usually, the setup that most people have is you'll give someone the G code and a setup sheet, and that's all they get at most, at best. Basically, they get the G code and a setup sheet. This is your tooling. Go and run it. And ultimately, they're asking you questions or bugging you. What shop floor is essentially doing is taking your G code, taking your setup sheet, taking a simulation of the program, taking all of your tool information, taking your CAD file and giving them a 3D representation of what it's doing so that you can do it. And it can do it on an op-by-op basis, but keeping all of the data stored in one kind of container file, if you will. So let me show you a little bit about what shop floor is doing. So essentially, let's close out of this, go in here. So you'll see now there's a publish shop floor function on here. And what you'll do is you'll hit publish, you publish it to a certain location, you can output the code or you can choose not to. You can output a setup sheet as well or choose not to. But essentially what you're getting is something that looks like this. It's like e-drawings, like I said. You can do things like simulate the toolpath. So you can see the stock information actually got passed over to here, but I can simulate it. So this is an operator simulating the program, but without the edit capabilities. So a lot of people don't like operators editing code, and they can't edit the code in here. It's a viewer. It's like e-drawings, basically. A viewer for viewing what's going on, what that toolpath is doing, so that the guys on the shop floor know exactly what that program is supposed to do, and they can detect issues before things actually occur on the machine, and they can verify setup things are okay and things like that. So you've got your full simulate capabilities. You can do this simulation, you can do your step through as well, and kind of see what's going on. So you can see a probing there and go into the different sides. You can kind of jump through the code and hop and say, okay, well, this bit is at this coordinate, it's supposed to be here, and it's at this angle and this degree and things like that, basically. You can even access the G code. So you can come in here, see what the code is. So when you go and say, hey, here's the code, it's all in this container file, essentially. So you can come down here and you'll check. You can come in and say, okay, the bore operations here, we've got the probing right here, check bore size. So I just output this earlier, so there was slightly different text in here, but it basically did program stop and put the comment in here as well. So you can see that, and you can also see the setup sheets. So this is a nice simple way of looking at a setup sheet, but maybe I don't know, you're struggling to figure out what protrusion is, or you're just reading a table. That's always not the greatest way of doing things. Well, why not have a look at the actual visuals? So in here, I can actually bring up all of my program right here. I can see where things like the probing, I can look at each operation basically. I can look at the tools and go, hey, actually, what does that tool reach look like? Oh, it was 1.6 inches. Great. Away I go. So you've got access to all of the tools, um, all the order of operations, so you can kind of see what's going on in here and just get more information coming out and make sure that the guys on the shop floor are actually producing what they're expecting to and getting the right information in a much clearer, more visual format. This is an optional license that you can get. It's not included in the main CAMWorks package, but it's a great new tool that you can use for doing it. The other thing that will come in here, it's not in here at the minute because I'm still on pre-release, but the reason I wanted to talk about the tolerance-based machining and basically annotating the model with those tolerances is the tolerance information will actually also pass into here. So it's not doing it on mine at the minute because, like I say, I'm in pre-release. But this one right here, this dimension that I put in as a reference for the operator or whatever, that will actually pass over to here because essentially this is a step file. It's using the new technology step 242, which supports product manufacturing information, PMI. So you can actually get all of your data across and it will actually show the annotations in here, and you can search for that PMI and things like that. There's a filter key. Mine's not coming in here because of a slight version mismatch, but in the release versions, it will actually come in here as well and give you all of that data as well. So that's shop floor, great new tool. The last thing that I wanted to talk about was just a few of the services we offer. At Hawkridge, we get a whole bunch of requests for all sorts of doing all sorts of different things. Things from, hey, can you customize the post? This post isn't quite working correctly. I liked what you had on the website, for example, but I need some changes to it or whatever. So you can download a post from the Hawkridge website, and if you feel like, yes, it's good, but I want a few slight changes to it, we can also customize that just so that you don't have to sit there editing code and things like that. If you're editing code, you really shouldn't be. Obviously, some situations you have to, but ideally, the ultimate goal is you don't want to have to sit there and check through that code. You want that machine to be running and the staff to be working at optimal pace, basically. We can output things like tool lists, as you saw in that shop floor document. We can customize things like safety lines and also things like hassle-free updates. This is a big one that I've just started talking about more because people didn't realize it, but CAMWorks added the probing functionality to 2020. That requires a post update. So rather than you having to recompile your post processes and stuff like that, all you would do with a custom post from us is basically contact tech support and say, hey, can I get my post updated with the new probing cycle capabilities or whatever? So every year there's enhancements and things like that. You just have to request the update. You don't have to sit there making sure that your post is working, because if you made it, it's up to you basically. Setup sheet customization. This one's been a big one recently. A lot of people wanting just to customize the setup sheet. So rather than having something that, if I open up that shop floor document again, rather than having something that looks basically very simple, let me just go and grab actually some files here. So we offer services to actually customize setup sheets and things like that. So if you wanted, this is a slightly different one that I'm going to open with the HTML document. But this is a slightly custom one that we basically built for a customer. They wanted a slightly different look to it, slightly different format, different information in here. We can customize these to what you require and build services from them, basically. So, and the way we approach it is we basically quote it out on a per job basis. But we can either match it to existing stuff that you already run, or we can just basically give you more accurate information so that you can send the right information to the shop floor through those as well. And then we also build custom machine simulators as well. So if you are doing 4 and 5 axis and things like that, virtual machine simulation is almost a necessity these days, just to make sure that you're not tying up that expensive machine testing code out and things like that. You want to make sure that when you give that machine code, it is good. Virtually machine it on CAMWorks Virtual Machine, check for crashes, check for over travels, simulate the programs, verify the machine movements, collisions, out of limits, and things like that. As machines get more and more complex, this gets more and more important to understand and go about your daily business safely. So we can build custom machine simulators for your machines and dial them in specifically to what you have and your size and your table size and your customizations and things like that. The last thing I wanted just to mention was just check out the company website. Go up to the company logo at the top up here, hit events. A lot of you might have done this to register for the webinar, but go up to the company, hit the events page, and just keep an eye out on some of the events. There's a huge number of events that we offer. People are doing all sorts of different roles these days, combined between manufacturing, simulation, communication tools, and all sorts of different stuff, even PDM. There's a whole bunch of webinars and events that go on throughout the year. So just check that company events page out. Just on the drop-down menu in the top corner there. And with that, that's it. Thank you very much for attending.